After completing this lesson, you will be able to describe cluster monitoring, describe the ways to choose the right monitoring solutions, list the features and considerations of Cloudera Manager for monitoring, describe the different categories of Hadoop metrics, list the different types of Hadoop metrics, list the steps to monitor a cluster by using Cloudera Manager. In the first topic of this lesson, you will learn about Hadoop Cluster Monitoring, the considerations involved in choosing the right monitoring solution, the features of Hadoop performance monitoring tools, categories of monitoring solutions, and Cloudera Manager. Building mission-critical systems or Hadoop clusters to host massive data for processing requires mechanisms to know their operational state and ways to gather and use performance metrics. Organizations always use some strategy or tool to monitor the clusters, systems within the clusters, and the various components. It is essential to keep the cluster humming. Hadoop, like most distributed systems, comes with a monitoring challenge because the monitoring system must know how the multiple components, services, and systems interact within a large cluster. Considerations to choose a right monitoring solution from various solutions available include scalability. The solution should be able to monitor small nodes as well as large clusters with thousands of nodes. Flexibility. The solution should be able to provide an overview of the health of the whole cluster as well as the health of the individual nodes and internals of Hadoop. Extensibility. The solution should be able to utilize the data gathered and stored by third-party extensions or plugins. Zero configuration. The user should be able to plug the solution into an existing cluster without additional configurations. Note that choosing the right monitoring solution is not limited to these above considerations. Monitoring the performance of applications running in Hadoop cluster is very important, and choosing the right monitoring solution is equally important. Cluster monitoring tools provide information on what has failed. However, they do not provide the reason for the failure. Application performance monitoring solutions provide information on what has failed and the reason for the failure. They can also send appropriate alerts. Here are some features of Hadoop cluster monitoring tools that can help organizations decide which monitoring tool or solution to choose. Application performance monitoring. Real-time visualization of application execution. Performance history and trend analysis. Consolidated monitoring across technologies. Custom views. Self-service troubleshooting. Application service level management. Task performance metrics. Multi-cluster support and reporting. Notifications and alerts. Compatibility. Cluster or node monitoring. Now, let's learn about the categories of monitoring solutions. Monitoring systems can be categorized based on two components. Metric collection. The solution should be capable of collecting metrics from a source such as a Hadoop cluster. Use of metrics. The solution should be capable of consuming, aggregating, and presenting metrics on dashboards. The solution should be able to use raw metrics for diagnosis and analysis and should provide alerts when required. Monitoring can be categorized into the following two types. Health monitoring. It includes checking if the desired service, node, and component is in the desired operational state. Performance monitoring. It is used to gain, gather, and use regular samples of performance metrics to understand the functioning over a period of time. Let's look at some examples of monitoring in the next screen. Monitoring examples include the following. Checking if each daemon is running with appropriate memory consumption when monitoring Hdfs. Checking if each daemon is responding to requests in the defined window of time. Checking the percentage of slave machines that are communicating with the master node or looking into block distribution on save nodes. Checking how applications are performing on top of Hdfs. Now that you know about Hadoop cluster monitoring, let's learn how Cloudera Manager is used for monitoring. Cloudera Manager consists of various features for monitoring the health and performance of components, such as hosts, services, and nodes, and the overall cluster. It also tracks the performance and resource demands of the user jobs running on your cluster. In addition to monitoring, Cloudera Monitor can also notify asynchronously when an important event of interest occurs. Cloudera Manager manages some of its helper services, such as Activity Monitor, Service Monitor, Host Monitor, Event Server, Reports Manager, and Alert Publisher. Cloudera Manager allows monitoring with ease without installing additional tools or configuration. The capabilities of Cloudera Manager for monitoring include the following: Hadoop services. Host agents collect health metrics for services such as Hdfs, HBase, Mapreduce, Zookeeper, Cloudera Impala, and Flume. These are forwarded to the service monitor checks. The health check results can be viewed at the service and role instance level. Information from specific metrics is collected, aggregated, and presented on dashboards or in form of charts. This helps diagnose problems. Health checks also embed recommendations of actions to fix issues. Hosts. Host monitoring allows you to view information related to all the hosts in the cluster, such as the up or down status of a host, current resident and virtual memory consumption of a host, role instances running on a host, rack assignment, and so on. User activities. Activity monitoring allows you to monitor the activities that are running on the cluster and the users running it. It allows you to view current and historical activity. Statistics related to resource consumption by individual users and jobs can be viewed in tables and charts. This can help in diagnosing behavior or performance problems. Report generation. Reports provide a historical view and current statistics pertaining to various aspects of the cluster. These reports are aggregated over select time periods, hourly, daily, weekly, and so on, and can be exported as XLS or CSV files. Alert notifications. Cloudera Manager can be configured to generate alerts on a variety of events based on thresholds. Enable and disable them, and configure email delivery of alerts on critical events. If alerts need to be looked into later, they can be suppressed temporarily for individual roles, services, hosts, or even the entire cluster to allow system maintenance, troubleshooting, without generating excessive alert traffic. Metrics collection. Metrics are simple numeric values applicable to a specific entity, such as CPU seconds. Cloudera Manager collects these while monitoring the entities within the cluster. Most of metric collection is done by Cloudera SCM agent. The metrics are then forwarded to the service monitor. Certain metrics are collected directly by service monitor, aggregated, and stored for further usage, like presentation or analysis. For example, the service monitor hosts an Hdfs canary test, which tries to write, read, and delete a file from Hdfs at regular intervals and checks for success and time taken. Using the Charts page in Cloudera Manager, users can query and explore the metrics being collected. Health Checks Service Monitor evaluates health checks for every entity in the system. It checks for disk space in every node or for successful checkpoint or connectivity of data node with name node. Service Monitor also helps in projecting status of a service based on health checks done on underlying daemons. When health checks go red, events are created and alerts are generated and sent to the concerned people. Here's a sample dashboard that displays Hadoop metrics related to Yarn from a small cluster. Stored metrics allow creation of multiple similar dashboards. Dashboards can also contain real-time metrics. Now, let's understand Hadoop metrics in detail. In the second topic of this lesson, you will learn about Hadoop metrics and the steps to monitor the health and status of services. Hadoop exposes various metrics. Each daemon can be configured to collect this data from internal components at regular intervals and then aggregate the metrics. Related metrics are grouped into named context, and each context can be treated independently. Some contexts, such as information about the JVM and RPC operations performed, are common to all daemons. Other contexts apply only to daemons of a specific service, such as Hdfs metrics, that come from only the name node and data nodes. All contexts are useful and necessary when monitoring for health, understanding performance, and diagnosing problems with a cluster. The four primary contexts are as follows. JVM. It contains Java virtual machine information and metrics, such as the maximum heap size, occupied heap, and average time spent in garbage collection. Metrics related to this context are produced by all daemons. DFS. It contains the Hdfs metrics. The metrics provided differ according to the daemons. For example, name node provides information about total Hdfs capacity, consumed capacity, missing and under-replicated blocks, and active data nodes in the cluster. Data nodes provide the number of failed disk volumes and the remaining capacity on that particular worker node. Only the Hdfs daemons output metrics for this context. Mapred. It contains Mapreduce metrics. The metrics provided differ according to daemons. For example, the job tracker provides information about the total number of maps and reduces the slots, blacklisted task trackers, and failures. Task trackers provide counts of running, failed, and killed tasks at the worker node level. Only Mapreduce daemons output metrics for this context. RPC. It contains remote procedure call metrics. Examples of data include the time each RPC spends in the queue before being processed, the average time it takes to process an RPC, and the number of open connections. All daemons output metrics for this context. Note that the metric system configuration is specified by the Hadoop Metrics properties file within the standard Hadoop configuration directory. Let's look at the implementation. The configuring plugins to handle metrics data are the following. Disabling metrics. These plugins disable access to metrics. Hadoop-metrics.properties jvm.class equals org.apache.hadoop.metrics.spi.nullContext. dfs.class equals org.apache.hadoop.metrics.spi.nullContext. Writing metrics to a file on file system. File context pulls the internal components of Hadoop for metrics periodically and writes them out to a file on the local file system. Hadoop-metrics.properties jvm.class equals org.apache.hadoop.metrics.file.fileContext. jvm.period equals 10. jvm.filename equals /tmp/jvm-metrics.log. dfs.class equals org.apache.hadoop.metrics.file.fileContext. dfs.period equals 10. dfs.filename equals /tmp/dfs-metrics.log. Hadoop integrates well with the open-source performance monitoring system Ganglia. Ganglia contexts include the following: org.apache.hadoop.metrics.ganglia.ganglia context, org.apache.hadoop.metrics.ganglia.ganglia context 31. Ganglia works by running a small monitoring daemon called gmond on each host. Gmond collects metrics locally. Each gmond process relays data to a central gmetad process that records data in a series of RRD or round-robin database files. These are fixture-sized files that efficiently store time series data. A PHP web application or Apache web server displays this data in a simple but effective view. Hash Hadoop-metrics.properties sample jvm.class equals org.apache.hadoop.metrics.file context. jvm.period equals 10. jvm.servers equals 10.0.0.xxx. The server value may be a comma-separated list of host port pairs. The port is optional, in which case it defaults to 8649. jvm.servers equals gmond-host-a, gmond-host-b, 8649. Hdfs.class equals org.apache.hadoop.metrics.file context. dfs.period equals 10. dfs.servers equals 10.0.0.xxx. Apart from normal Hadoop metrics, traditional system resource data such as CPU, memory, and input-output can be collected, gathered, and presented or utilized. After choosing the correct monitoring system or tool, it is also important to decide the following. Which metrics are important? Which metrics represent the health of monitored services? What are the thresholds set to indicate issues and generate alerts in alignment to the cluster usage and growth? Hadoop metrics can be categorized into the following: Hdfs metrics, Mapreduce counters, Yarn metrics, Zookeeper metrics. Let's learn about the different categories in detail. Hdfs metrics can be further dissected into the following. Name node metrics. Name node metrics report metrics on themselves and can do the same for data nodes. These can be further divided into the following. Name node emitted metrics. Name node JVM metrics. Data node metrics. These are host-level metrics that are specific to particular data nodes. Let's learn about the two metrics in detail in the following screens. Some metrics emitted by name node are as follows: capacity remaining, missing blocks, num dead data nodes, files total, total load. Capacity remaining represents the total available capacity remaining across the entire Hdfs cluster. Data nodes that are out of space are likely to fail on boot. Running data nodes cannot be written to. In addition, any running jobs that write out temporary data may fail due to lack of capacity. It is a good practice to ensure that disk use never exceeds 80% capacity. Missing blocks are corrupt or missing blocks that can point to an unhealthy cluster. Upon receiving a read request, a data node will typically locate the requested block and serve it to the client with a checksum for the data. If the checksum for the received data does not match the stored checksum, the client reports the corruption to the name node and reads the data from one of the other replicas. The name node, meanwhile, schedules a re-replication of the block from one of the healthy copies, and then tells the original data node to delete its corrupted copy. So although you may see corrupt blocks reported on your cluster from time to time, that does not necessarily mean that you have lost data. A missing block is worse than a corrupt block. A missing block cannot be recovered by copying a replica. A missing block represents a block for which no known copy exists in the cluster. However, that does not mean that the block no longer exists. If a series of data nodes were taken offline for maintenance, missing blocks may be reported until they are brought back up. You may not care if you have a corrupt block or two in the entire cluster, but if blocks go missing without any scheduled maintenance, it is cause for concern. Ideally, the number of live data nodes will be equal to the number of data nodes provisioned for the cluster. If the number of live data nodes drops unexpectedly, it may warrant investigation. Num dead data nodes, on the other hand, should be alerted. When the name node does not hear from a data node within 30 seconds, the data node is marked as stale. If the data node fails to communicate with the name node within 10 minutes after the transition to the stale state, the data node is marked as dead. The death of a data node causes a flurry of network activity, as the name node initiates replications of blocks lost on the dead nodes. Though the loss of a single data node may not impact performance much, losing multiple data nodes will be very taxing on cluster resources and could result in data loss. Files total is a running count of the number of files being tracked by the name node. Name node stores all metadata in memory. As the number of files, or blocks, or directories tracked increases, the memory required by name node also increases. The rule of thumb for name node memory requirements is that each object, file, directory, and block, tracked by the name node consumes roughly 150 bytes of memory. If each file is mapped to one block, files often span multiple blocks, that is approximately 300 bytes per file. That doesn't sound like much until you factor in the replication of data. The default replication factor is 3, so 900 bytes per file, and each replica adds an additional 16 bytes, which results in a total of approximately 1 KB of metadata per file. That may still not sound like much, but as your cluster expands to include millions of files, you should keep this number in mind and plan to add additional memory to your name node. Total load is the current number of concurrent file accesses, read, write, across all data nodes. This metric is not usually indicative of a problem, though it can illuminate issues related to job execution. Since worker nodes running the data node daemon also perform Mapreduce tasks, extended periods of high I/O indicated by high total load generally translate to degraded job execution performance. Tracking total load over time can help get to the bottom of job performance issues. Name node runs in Java Virtual Machine. Therefore, it depends on Java garbage collection processes to free the memory. More activity in cluster triggers more garbage collection processes. Note that excessive pauses during garbage collection can be fixed by upgrading JDK version or garbage collector. Additionally, Java runtime can be tuned to minimize garbage collection. Some of the metrics emitted by data node are as follows. Remaining. This points to the remaining disk space on data nodes. As mentioned in the section on name node metrics, running out of disk space can cause a number of problems in a cluster. If left unrectified, a single data node running out of space could quickly cascade into failures across the entire cluster, as data is written to an increasingly shrinking pool of available data nodes. Tracking this metric over time is essential to maintain a healthy cluster. Num failed volumes. This shows the number of failed volumes among the total number of disks or volumes in data nodes. By default, a single volume failing on a data node will cause the entire node to go offline. Depending on your environment, that may not be desirable because most data nodes operate with multiple disks. If you have not set dfs.datanode.failed.volumes.tolerated in your Hdfs configuration, then you should definitely track this metric. Remember, when a data node is taken offline, the name node must copy any under-replicated blocks that were lost on that node, causing a burst in network traffic and potential performance degradation. Mapreduce framework exposes a number of counters to track statistics on Mapreduce job runs. These counters can be further categorized into 4 types: job counters, task counters, custom counters, file system counters. These counters can be viewed from Hue Job Browser, Terminals, Resource Manager, and Node Manager Web UI. Some of Mapreduce counters generated by Mapreduce framework are millis_maps, millis_reduces. These metrics track the time spent across all map and reduce tasks. num_failed_maps. num_failed_reduces. These metrics track the number of failed Mapreduce tasks of a job. Data_local_maps. rack_local_maps. other_local_maps. These counters track the number of map tasks that were performed, aggregated by location. Task counters. These counters track the results of task operations. Task counters represent the total operations across all tasks associated with a particular job. Some of the counters here are reduce_input_records. Number of input records for each reduce task in a job. GC_time_millis. These metrics help determine the percentage of time spent performing garbage collection. Yarn metrics can be categorized into the following three types: cluster metrics, application metrics, node manager metrics. Let's learn about these metrics in detail. Cluster metrics provide information pertaining to Yarn application execution. The table lists some of the cluster metrics generated by Yarn framework. Unhealthy nodes. Yarn considers any node with disk utilization exceeding the value specified under the property yarn.node-manager.disk-health-checker.max-disk-utilization-per-disk-percentage in yarn-site.xml to be unhealthy. Ample disk space is critical to ensure uninterrupted operation of a Hadoop cluster, and large numbers of unhealthy nodes impact performance. Active nodes, lost nodes. The active nodes metric tracks the current count of active or normally operating nodes. Nodes can lose contact with the resource manager for a number of reasons, including network issues, hardware failure, or a hung process. It is good to be aware of lost nodes, so you can take action if the node never returns. Apps failed. If the percentage of failed map or reduce tasks exceeds a specific threshold, then the application as a whole will fail. Total MB, allocated MB. When taken together, the total MB and allocated MB metrics give a high-level view of your cluster's memory use. Memory is currency in Hadoop, and if you are nearing the limit of your memory use, then you have a couple of options. To increase the memory available to your cluster, you can add new node manager nodes, tweak the amount of memory reserved for Yarn applications, or change the minimum amount of RAM allocated to the containers. Keep in mind that Yarn may overcommit resources, which can occasionally translate to reported values of allocated MB that are higher than total MB. Application metrics provide detailed information on the execution of individual Yarn applications. One of the metrics generated by Yarn framework that is specific to applications is progress. Progress provides a real-time window into the execution of a Yarn application. Its reported value will always be in the range of 0 to 1 inclusive, with the value of 1 indicating completed execution. Tracking this can help in determining the causes of performance degradation. Node manager metrics provide resource information at the individual node level. Containers failed tracks the number of containers that failed to launch on a particular node manager. Launching of containers may fail due to node manager's disk being full or due to heap memory being very less. A centralized coordination service plays an important role in Hadoop deployment. If high availability is enabled, monitoring Zookeeper metrics can be beneficial. The metrics exposed by Zookeeper are as follows. ZK_followers, leader only. The number of followers should equal the total size of your Zookeeper ensemble minus 1. The leader is not included in the follower count. If the ensemble fails to mention the quorum, then all the automatic failover features are suspended. ZK_AVG_latency. The average request latency is the average time it takes, in milliseconds, for Zookeeper to respond to a request. By tracking the average latency over time, it is possible to better correlate errors that may have been caused by stale data. zk_num_alive_connections. Zookeeper reports the number of connected clients via this metric. This represents all connections, including connections from non-Zookeeper nodes. Apache Hadoop core distribution does not offer any inbuilt monitoring services or tools to monitor the cluster. NameNode Web Interface UI and Resource Manager Web Interface UI can be used to browse information about cluster. To monitor cluster, gather metrics, and view them, integration with third-party software such as Ganglia and Nagios would be required. Features of Cloudera Manager Service Monitoring include monitoring service health performance metrics about the services, role instances running on the cluster, and metrics against configurable thresholds. Presenting health and performance data in a variety of formats, including interactive charts. Generating events related to system and service health, and critical log entries, and making them available for searching and alerting. Maintaining a complete record of service-related actions and configuration changes. To check the status and health of a service, click on Services tab under Cluster tab and select All Services. This shows the following: type of service, service status, overall health of service, type and number of roles configured for the service. Note that the services show the current status of a service. Earlier status of a service can be seen by adjusting the time marker in Cloudera Admin interface. The demonstration in the next screen shows the steps in detail. Monitoring your CDH cluster. In this demo, you will learn monitoring Cloudera cluster using inbuilt helper services. First, click on Clusters, followed by the cluster that you have created. You can see all the services on the screen which are in your cluster. You can also see that all the services under Status tab are green, which means all your services are in good health. Click on Hdfs, and you will find the summary of Hdfs service, which is displayed in the form of graphs. These graphs are generated by inbuilt monitors. Status Summary displays the status of all the different roles which belong to Hdfs service. Click Instances. You will find the status of federation and high availability, along with the details of NameNode and role instances with status. Click on Clusters, and you can see that there are some configuration issues. Click to check the respective configuration. To fix the issues, click Suppress and check Suppress for all hosts. You can write a comment if required. And click Confirm to close. Now click Host tab and click All Hosts. You will see the details related to hosts which are in good health condition. You can find the details like last heartbeat sent, load average, disk usage, and physical memory. Select any host and click Actions to check the options related to administration activities. Other options under Filters are Cluster, Cores to check the number of cores, Commission status, Last heartbeat, Load status, and Health tests. Click any health test and clear if not required. Click Diagnostics, then Events. You will see the events that have happened in the cluster. Click Audits tab, and you can add different filters by clicking Add a Filter to check on a particular machine, a command, a username, an IP address, a role, or a service. Click on Charts, and then Chart Builder. Charts are used to monitor specific areas of cluster. Click Clusters, and then click Utilization Report. You will find different kinds of metrics. CPU utilization, which tells you about the CPU utilization of a cluster by total CPU cores. Average utilization, maximum utilization, and average daily peak. Memory utilization is the next tab under Utilization Report, which tells you about the total physical memory, average utilization, maximum utilization, and average daily peak. Click on Yarn to check the processing-related information. Click Configure, and you will find an option, Enable Container Usage Metrics Collection. Check Yarn, MR2 included, service-wide, and you can write a comment in the Comments tab and click Save Changes. Now you can see the information below CPU utilization and memory utilization related to Yarn. Click on Capacity Planning, which contains more information related to queue. Preemption tuning is required to tune a particular queue. Click Clusters, and then click on Cluster 1. There is a critical health issue with Yarn. Click on the issue icon, and then on Yarn, MR2 included, to check the issue. The error is, failed to get user to run Mapreduce job aggregate Yarn container usage metrics. Click Configuration. Error is with container usage Mapreduce job user. Type Hdfs, which is an admin user. Click Save Changes. Click Applications, which contains the workload summary of different applications that are running on your system. Currently, there are no applications that are running. Click Charts, which will be displayed once the memory is allocated. Mouse over on every option in Workload Summary to get some information about an option. Click Resource Pools, which will give details on the type of scheduler that you use. Here, Fair Scheduler is not configured yet. Click Close and go back to your cluster. You can still see the issue with Yarn, and it can be fixed by performing a restart. To restart, go to Actions, click Restart, and confirm Restart. In this way, you can monitor your services, roles, and the status of roles and services. You can collect specific metrics related to applications, roles, and services. This brings us to the end of the demo on monitoring your CDH cluster. Monitoring your CDH cluster 2. This demo contains some more options related to monitoring your cluster. You are on the admin interface, where you can see the charts related to cluster CPU, cluster disk I/O, cluster network I/O, and Hdfs I/O. You can place the cursor anywhere on the graph to get specific information at any point of time. Click Clusters, and then Cloudera Management Service, which will display different roles related to Cloudera Management Service. Under Status Summary, you have Activity Monitor, Alert Publisher, Event Server, Host Monitor, Reports Manager, Service Monitor, and Hosts. On the right side of the screen, you can see some charts which give details about the CPU cores used, health, important events and alerts, critical events and alerts, Cloudera Manager JVM heap memory usage, Cloudera Manager database, host monitoring metric storage, service monitoring metric storage, Impala query monitor storage, and Yarn application monitoring storage. Now click Activity Monitor, which will display the health test results. You can also click on Heap Dump Directory Free Space. First, you will see the details of the test. Then you will see whether the test is enabled or disabled. You will find some action commands which can be considered, and there is also an Advice tab, which gives you advice related to Activity Monitor. Go back using the arrow in the browser and click Configuration. It will show an alert. Click Cancel, and you will be taken to Configurations page, which is related to Activity Monitor. If you make any changes in Configurations page, you need to restart the service to reflect the configuration changes. Click Processes, and you will find the information related to processes which are monitored by Activity Monitor. Click Commands to check the recent commands that were performed. Click Charts Library to know the different aspects related to Activity Monitor. Activity Monitor Storage shows you the details related to usage of Activity Monitor. Process Resource gives you the information related to role of CPU usage, JVM heap memory usage. Host Resources gives you the information in different tabs like CPU, memory, disk aggregate, disk comparison, network aggregates, network interface comparison, and file descriptors. Click Log Files, where you have details about role log file, stdout, and stderr. Quick Links gives you information about alerts, critical, and all. Go back to Activity Monitor, and to check different health checks that were performed, click on Show, which is on the right side of each health test, or click on the arrow on the left of each health test to know more about the test. Now go back to Cloudera Management Service. Click Alert Publisher, where you can find the details and charts related to health tests of Alert Publisher. At any point of time, you can change the duration for resetting the graphs. You also have additional options like default, reset content, reset layout, and so on. Click on Processes to know the processes that are under Alert Publisher. Click on Commands, Charts Library, and so on to know more about Alert Publisher. Now, click on Clusters and then Cloudera Management Services. Click on Service Monitor, which will give you the information related to services. You can click on any option, like Configurations, Processes, Commands, and so on. To know more about Service Monitor. If there are any jobs that are running, click Clusters and then click Yarn. In Yarn, click Web UI, then click Resource Manager Web UI, IP 10.0.0.162. Now you will be able to see different applications that are running along with the status of each application. Click Scheduler to check the scheduler that has been configured. Click Applications in Yarn. As there are no applications that are running, there will be no data. These are the steps involved in monitoring cluster to check specific information related to services, hosts, roles, different monitors, and different aspects of your cluster. This brings us to the end of the demo on monitoring your Hadoop cluster.